Our next discussion is going to be about intelligence at the edge. It's the senior research scientist and Internet of Things analytics lead from Intel. She is here with us today. Please give a warm round of applause to Jennifer Healey. Hi, Jennifer.
Hi.
Good morning. Come in.
Thank you so much. Thank you very much. It's wonderful to see you all here, and it's wonderful to be here at CeBIT to get a chance to talk to you about something that's very important to me, which is my perspective on what I see as the future of the Internet of Things. Now, I know you've heard a lot about the Internet of Things throughout this conference. It's an extremely important topic. It's a topic that will revolutionize the way we live our lives in the next decade and beyond. Now, but I want to tell you, as I often hear the Internet of Things talked about in these sort of abstract terms, but what I would like to start with is a story that brought me from my research in transportation to my research in the Internet of Things. And it's a story about driving. I used to research the experience of automobiles and how people experience driving in their daily lives. And as part of this research, I went around the world with ethnographic researchers. I put sensors in people's cars. I put app monitoring on their phones to get a picture of what they were trying to do while they were driving, and what driving was like in Germany versus China versus Brazil versus the United States. And it's one of these stories that I want to share with you now. And it's a story of a very nice man who picked up his friend, then went to the airport to pick up another friend, and then drove them both to dinner. Now, what you're seeing here is a plot on Google Maps of the speed of his transit as he went from his home, and then to the airport, and then to downtown. The light green represents traveling at over 70 kilometers per hour. We don't get into details. But it's quite a good drive. The only problem he encounters is, you see this nasty little orange and red blob, and I'm going to just blow that up for you. This is a sad story. This is a story of his parking situation. And because I have a time-stamped computer in his car, I know that for sure he spent over 40 minutes trying to find a parking space. He's very nice. He dropped his friends off. And then for the next 40 minutes, time-stamped by a computer, no exaggeration, he went around the city searching for parking. Now, everything we were trying to do to improve the driving experience could not address this, because the problem isn't with a bigger engine. The problem isn't with the IVI or how you were interacting with the car. And I started to think, well, will even autonomous driving help this situation? And the answer is actually no. Because as good as autonomous driving is, one thing it would be really bad at is finding a parking space, because that requires the sort of general intelligence that is not programmed in with the current LiDAR tracking system. What would help this situation is if the parking spaces could communicate their information to the car. That would even help the autonomous driving. We don't want lost autonomous cars driving around endlessly clogging the city streets either. What we need is an Internet of Things solution, where the parking spaces are able to communicate information to the car. And at first, like all Internet of Things, it sounds so easy. All you have to do is put a little sensor on a parking meter and throw it back to the cloud. Well, we looked into this, and the problem is that parking is variously owned. There are public parking spots. There are ones in private lots. They have various different kinds of sensors, and each of them has their own private cloud, and they don't necessarily want to share information, because you need pricing information, you need availability. So what we have, instead of the Internet of Things, we have the heterogeneous intranets of things, that all need to be managed and come together to answer questions about even a particular location. And my talk is going to be about specific locations and why we need intelligence that is dedicated to understanding, in context, the Internet of Things in particular situations, which is what I'm calling the edge. So this is a diagram about how people talk about the Internet of Things. There's a data center or cloud. It's actually a vast multiplicity of private clouds right now. It's not one thing. How you connect, and then everything at the gateway and below is considered the edge. And it's often assumed that the edge is very simple. And in my research, going out and talking to customers, I found that the edge is not at all simple. And we are going to need far more intelligence to manage the ever-growing and ever more complex edge than I believe people currently think. And just to give you an example of why I think so, I'm going to talk again about my research in cars. Now, from the Internet of Things perspective, a car is an edge. It is a thing. When you connect a car to the Internet, it is the edge node. However, you peel back the layer and you look at what's under the hood of this edge. Inside a car, you have hundreds of embedded controller units. You have a controller area network with its own programmable logic controller that manages hundreds of sensors just in this one thing. And it turns out it's not even that simple. Originally, if you wanted to send data around this controller area network, you just grabbed the bus and you sent your data. But it turns out some data is more important than other data. Your windshield wiper fluid may be low, but that's not as important as the fact that you're turning the steering wheel right now. So they had to split the bus and separate the high priority and the low priority data. So within this thing, there are hundreds of sensors, 2 logic controllers, prioritizing data and sending it along 2 entirely different buses. And the fact is, it's not getting simpler. It's getting more complex because people want even more sensors. And they don't necessarily want the simplest sensors either. People want very complex sensors. They want 3D laser range finding. It has an incredibly high data rate. People want multiplicities of cameras. These also have extremely high data rates. So now, in addition to having a low priority bus and a high priority bus, and potentially other buses within your car, now people are looking for gigabit level Ethernet in their car to handle autonomous driving systems, and this is still all considered an edge. The edge is going to get more and more complex, and we're going to have to manage it locally because you cannot send this data back to the cloud. It's obvious in the case of a car. A car's driving around at 70 kilometers per hour. You're not going to hit the brakes, send that back up to the cloud, have it incorporated, and have the cloud get back to you before something happens. People talk about doing real time in the cloud. It's important to lower cloud latencies, but if you really need real time, you need to do processing locally. And there are a lot of cases where it just makes sense to do the processing locally. There is no need for a bit of data to go from your windshield wiper fluid low sensor to the cloud and then back to your dashboard, when it can just go to your dashboard. Now, you might think that a car is certainly an exception. It's a very complicated piece of equipment. It has more sensors than I could possibly imagine on anything. Certainly, this is an anomaly in the Internet of Things. There is no other thing that could possibly be like this. What if I just wanted to connect my toothbrush to the Internet of Things? Certainly, I don't need all this. What if I just want to connect a simple piece of equipment to the Internet of Things? Certainly, I don't need this kind of complexity. So one of the things that we've looked into is a customer who wanted to hook an HVAC system up to the Internet of Things. And they had a very simple reason for doing so. People didn't want to go up onto a snowy roof to have to reprogram it. They just simply wanted to connect it to the cloud so that they could potentially do updates to it remotely. It sounded very simple. It's the classic Internet of Things. I just want my thing on the Internet. That's all. I just want it to talk. Because the way these things are currently programmed is the way a lot of these minimally programmed industrial pieces of equipment are programmed. They're programmed when you buy them. They're programmed in the factory. They're programmed in a graphical language, and it's pretty much that's it. They're programmed in the factory, and then they're shipped, and that's the end of it. You never see them again, and you never touch the set points. In fact, you pay for the set points when you order it. And in order to change it, it's a really big deal. And people wanted to make that easier. So what you have is a piece of equipment, very simple programming, that you cannot update. And this is the classic problem with the way the Internet of Things is now, and it's one of the arguments why everything should be in the cloud, because the programming is just too simple, and it's better to just throw all the data back to the cloud. Well, that's great, except that you don't know anything about the actual situation of the piece of equipment that you're seeing. The cloud, when you ship the data back into the cloud, it becomes devoid of context. What you get from having local intelligence at the edge is you have access to all the context of the machine. The temperatures you experience in the winter in Minnesota in the United States, which is where this was taken, very cold. It's normal that it's that cold. If it was in the desert in Arizona, it would be normal that it was that hot there. So often the decisions that you want to make for a thing that's connected on the internet, for what is anomalous, have to do with a lot of other sensors that can be pulled locally. Right now, with the simple sensor, we don't even know where this piece of equipment is located. We have an external temperature sensor, and we want to make a decision about, well, is this temperature abnormal? Or even people want to make a more complex decision. They say, well, how much is it going to cost me to lower the temperature by 3 degrees over the next 3 hours? And it turns out to answer that question, the simple logic can't handle it, because you need data that's not available. You want to know what's the local temperature, what's the local weather going to be like over the next 3 hours, what's the state of my system, how much has it typically costed me to operate it at a certain energy level, and how much is the energy pricing going to be over the next 3 hours? And offer to answer these questions in this situation, you have to contact a multiplicity of different clouds that are owned by different people. The weather service cloud, the energy cloud. You have to look at this particular machine's maintenance history. You have to find out what the operating characteristics are of this particular machine. And then you have to make the decision. And all of these decisions could be made locally in this one unit, because you have the context right there. You have access to the external temperature. You know where you are. You can draw all this data in and making this decision locally, instead of sending all the data back to the cloud and then having a multiplicity of clouds come together in the cloud and then come back to make a decision that could otherwise have been made in real time. What we found is that the programming in these industrial units is far too simplistic, and that there's a demand for more intelligence at the edge to be able to deal with multiplicities of clouds, multiplicities of sensors, and be able to make a super intelligent decision in place so that you can efficiently manage these machines where they are. And one of the biggest problems isn't just when you have one unit working on its own that's been programmed at a factory. The problem comes when you start to have a multiplicity of units that have all been programmed at the factory and then let into the field. Now, each of these is working independently. They're working independently on a very simple program that was programmed in them at the factory before they ever got into the world. And they're operating, and what happens is one of them doesn't know about the other one. They don't have that kind of intelligence. What people want is more intelligence at the edge to manage more sensors and get the context of each one of these pieces of equipment so that this equipment has a sense of itself. It has a sense of where it is. It has a sense of what is going on around it. And it also has a sense of where the other HVACs are on this same rooftop so that it can interact with them and they can make a more efficient system. And this might even sound simple. Well, OK, we'll just have a coordinating intelligence. We'll have one big coordinator that will sit, and it will look at each and every one of these units and be able to mediate between them. What happens with that is each one of these units may not even come from the same manufacturer. So what you have to do at the edge is be able to address each and every one of these by the protocol with which it is expecting, so that you can get the data you need from this model, the other model, the other model, and then you can make a plan to regulate how these things are going to work together. And this is just on a rooftop. So not only do each of the individual things need more intelligence to understand their context, to understand what's normal for them, you need another layer of intelligence to manage groups of things, local groups of things on the same rooftop, such that you don't have one air conditioner trying to cool a room and another air conditioner trying to heat the same room because they have conflicting set points that were set 5 years ago at 2 different factories. Often the solution that is put forward is we'll just send everything back to the cloud. But sometimes it's not even clear which cloud you're sending it back to. If one company has a thing that sends information back to its cloud, and the other air conditioner has a different company and it's going back to its cloud, those 2 clouds need to negotiate with each other if we're going to have an efficient system. So perhaps there could be one super cloud in charge of all the proprietary clouds. That's one solution. Another solution is to think about, let's have some intelligence at the edge, not only to manage the multiplicity of sensors that are getting ever more dense and ever more complex, because people want to know just more and more and more about their machines, but also to manage the multiplicity of private clouds to which this data is individually being sent. The decision needs to be made locally. We could have an intelligence that was local deal with everyone's private cloud looking up and everyone's individual proprietary, often, data protocol that's coming in from below just to make a decision of what it means to keep this room at 70 degrees Fahrenheit. One of the biggest problems with the Internet of Things that is not often talked about is the fact that most of the data coming from things is variously owned. And it takes some sort of a coordinator to make sense of it in a local context. And this is what we found for parking. This is what we find whenever we try to actually implement efficiencies in systems. Different sensors, proprietary protocols that all need to be managed in order to work seamlessly together. So we need intelligence at the edge to manage our data, both because the sensors are different. There's different ways to detect how a parking space might or might not be occupied. These include, a very low data rate embedded coil that can tell you if a car is present. It won't tell you if a motorcycle is present sometimes. It certainly won't tell you if a lightweight car is sometimes present, so those can be wrong. So people often augment those with cameras. So now you have a very low data rate sensor and a very high data rate sensor running computer vision. And what you need to do is find the right solution that is going to be able to handle computer vision data, low data rate coil data, parking meter data. So let's say you went and you paid for your parking, you turned it to a certain level, there's a certain amount of minutes back. That's very low data rate data. And often these things all go on their own buses that were built to accommodate the data rates that they generate. And what we need is an intelligence at the edge that can put these pieces together so that you know it's this camera looking at this parking spot and this parking meter that is all relevant to this one location, so that you can make sense out of this one location. The idea of locality is important, such that when you're driving around, you know what things are near you, and you can contact the right networks to get the right information to say, you know, this is an available parking space, this is not an available parking space, and be able to take the data from a multiplicity of private and public networks and bring them to bear on your problem. Only when we have sufficient intelligence to abstract out what is normal, what is abnormal, and to abstract out what data we want to be sending back to the cloud, and to be able to communicate between multiple sensors at a particular location to make the right decision in time, we'll be able to have an Internet of Things that makes functional sense. So then finally, when we go and we pick up our friend at the airport and we drop them off at a fancy restaurant, we'll be able to make a local query to multiple different intranets of things from multiple different parking garages, so that we can finally be able to find the parking space that will allow us to actually join our friend for dinner, instead of having to drive around for 40 minutes hoping that they will, hoping to find with our own human eyes the right information that we could find from the Internet of Things. And that's my primary message. And I'm a bit early ending. So I'd like to ask you, sorry.
We've got a couple minutes for questions. I want to ask, I think this is great. This is a great idea. Is this an interim step, though, to the time when we have cars that drive themselves, and when we can say, okay, I want to go to this restaurant, and the car will communicate with these intranets and find a parking space so that we won't even have to deal with it anymore?
So that's part of the problem. I've worked for a long time with autonomous vehicles, and they're very good at avoiding collisions, and they're very good at driving themselves. But what they're not good at is interpreting computer vision scenes, such as to know when someone's about to leave a parking space.
Right.
The way that we as humans intuit how a parking space might become available is actually really complex the way we do it. We look for, we start tracking people. Is that person going to their car? And then we might make a prediction about, well, I see a pedestrian walking, and they seem that they might be getting their keys out, and they seem like they might be going to their car.
Yeah.
And that is incredibly difficult.
Right. Well, I mean, it's predictive. We're engaging in predictive behavior thinking, right?
And you're using a lot of human intuition. You know what it means as a human to need to go get your car. You know that you take your keys out of your pocket.
Right.
You know that, so you know what it looks like when someone's maybe looking to return to their car versus, on their way somewhere, hurriedly walking down the street. That's incredibly difficult for computer vision to do.
Yeah.
And it's incredibly difficult for autonomous cars to do.
Yeah.
Now, they can wander around, and if there's a lot of available spots, they can easily find one, and they can easily park. But finding parking is actually extremely challenging for autonomous vehicles.
Yeah, I think it's one of the biggest headaches that all of us deals with all the time. If you can come up with a way to solve that, I guarantee you will be nominated for a Nobel Peace Prize. Okay, any questions from the audience for Jennifer? I mean, fascinating presentation. Any more questions? The parking situation is solved. Final question I'd like to ask you, Jennifer. What about artificial intelligence? How about that coming into the equation here? Would that help, solve this problem too, if our cars had some type of artificial intelligence, or where these intranets and these parking garages, for example,
Yeah.
if they could anticipate human behavior.
Well, what I'm actually trying to advocate for is artificial superintelligence. Now, when people talk about artificial intelligence, they often talk about artificial human-level intelligence.
Right.
And that would mean teaching a computer vision algorithm to recognize behavior in people that would indicate they're going to a car so that we could make the decision the way people do. That's wrong. That's inefficient. That's not wrong, it's inefficient, because it would be much simpler if beyond the scope of our eyes, a parking space could let us know that it's about to become available because it's sensing a car move off outside of our human vision. So superhuman artificial intelligence is what the Internet of Things will give us. We just need to manage it. We need to manage all of this sensor data information in a way that allows us to sense-make in place. And that's going to require intelligence at the edge.
Do you want to give us maybe a timeline, a time horizon when this super artificial intelligence will be readily available?
You'll see it in stages? No, I mean, seriously.
But by the end of this decade?
I'm hoping by the end of this decade, even something as simple as a traffic light broadcasting when it's going to change, so that you know when to brake in advance. Right now, in the works, people are fuel efficiency. If you want to talk about delivery trucks, they want to know when they need to start braking. So if the traffic light could just communicate to them, look, you're not going to make this light, start slowing down now, that curve for braking can be much more fuel efficient with the information from the from the traffic light when it's going to turn. Now, I'm from the US, and I've noticed since I've been driving a manual car here in Germany, you do have this nice red, yellow flash to let you know when to get in gear.
That's true.
We don't even have that in the US.
Yeah, I've often wondered why we don't put that in the United States, because it allows you to prepare to drive.
So that's predictive intelligence. That's, in a way, that is what we're talking about. You may not recognize it as such, but we all drive automatic cars in the US, so it's not as important.
So it makes a difference. Jennifer, thank you very much. Excellent presentation. Thank you. Give her a round of applause, everybody.